Hello everyone. Greetings from the Department of Orthodontics. In this lecture, we learn about soldering. The statement of this lecture is at the end of the lecture, you should be able to describe the procedure of soldering in detail. The learning objectives are you should be able to define the liquidus solidus temperature, soldering, brazing. You should be able to explain the substrate metal for soldering. You should be able to describe flux and anti-flux. You should be able to classify soldering and describe various methods of soldering. Coming on to the definitions. First, we'll know about the definition of soldering. So soldering is a process that joins metals by heating them to a suitable temperature below the solidus temperature of substrate metal and applying a filler metal having a liquidus temperature not exceeding 450 degrees Celsius that melts and flows by capillary attraction between the parts without appreciably affecting the dimensions of the joint structure. Second comes brazing. So brazing is a process joining closely approximated solid metal parts by heating them to a suitable temperature, again below the solidus temperature of that part, and allowing a filler metal having a liquidus temperature more than 450 degrees Celsius to melt and flow by capillary attraction between the parts without appreciably affecting dimensions of the joint structure. So by these definitions, we come to know that the only difference between soldering and brazing is the liquidus temperature of the filler metal or the solder. In soldering, the liquidus temperature of the solder is below 450 degrees Celsius, while in brazing it is more than 450 degrees Celsius. So here we have to understand what is the meaning of liquidus temperature and a solidus temperature. Liquidus temperature is the temperature at which metal of an alloy system begins to solidify on cooling or becoming totally liquid on heating. Example, ice. Solidus temperature is the temperature at which metal of an alloy becomes completely solidified on cooling or start to melt on heating. Next comes the classification of soldering. So there can be two types of classification for soldering. First classification is torch soldering or oven soldering, and second type of classification is freehand soldering and investment soldering. So most commonly used procedure in dentistry is torch soldering and freehand soldering. So what all is needed for soldering? First, we need a substrate metal, or it also called as basic metal, flux and anti-flux, filler metal or solder, and a heat source. So what is substrate metal? Substrate metal, also known as a basic metal, is a pure metal or alloy. It is prepared for joining to another substrate metal or alloy. In the figure you can see that material 1 or material 2, they can be same or they can be different, and they can be joined together with the help of a solder. The composition of a substrate metal determines its melting range, the oxide that forms on the surface or during heating, the type of flux required for soldering, and flux is used to reduce the oxide layer formed, inhibit further oxidation, and it facilitates its removal. And also the composition determines the wettability of the substance by the molten solder alloy. Next comes the flux. The Latin word flux means flow. Flux prevents the formation of oxides. It facilitates removal of oxides and other undesirable substances, and it increases the flowability of the solder metal over the substrate metal. The purpose of flux is It removes the, as I said earlier, that it is used to remove oxide layer. It increases the flow of molten solder, thereby increasing the strength of the soldered joint. We need to note that the excess use of flux should be avoided, as it can weaken the joint. Types of flux. The flux can be of various types. First is surface protection type, second is the reducing agent type, and third is the solvent type. The commonly used fluxes are composed basically of boric acid and boric compounds, and some of the other flux use fluorides. Boric and borate compound flux has following composition. Borax glass is 55%, boric acid is 35%, and silica is 10%. Borax glass and boric acid act as a protective agent and form a low temperature glass. Fluorides are used on base metal alloys that are usually combined with borates. They help to dissolve more stable chromium, nickel, and cobalt oxides. An example of fluorides are potassium fluoride. Fluxes are supplied, they can be supplied in the form of liquid, paste, powder, fused onto the solder, pre-flux solder in the tube form. Again, as I said earlier, we should note always that we should minimize the amount of flux used. Excess flux remains trapped within the filler metal and cause weakened joints. Next is the antiflux. Antiflux is a material that is used to confine the flow of molten solder over the metal being joined. The commonly used antiflux are lead pencil markings, graphite lines, and iron rogue. Next, we need to know the solders used. Previously, gold solders were popular, but later on, because of its high cost value, it was overcome by silver solders. So gold solder are composed of gold, silver, copper, tin, and zinc, whereas silver solders are composed of silver, copper, silver, copper, zinc, tin, and indium may be present to lower the fusion temperature and improve the solderability. Silver solders are most commonly used in orthodontic soldering because of their low fusion temperature and easy handling characteristics. Now, what are the properties of dental solders? The fusion temperature should be at least 50 degree less than the substrate metal. Gold solder has gold solders are melted at 690 degrees to 870 degrees Celsius, and silver solders have fusion temperature of 620 to 650 degrees Celsius. Next is the flow. Good flow and wettability of the parent metal by the solder is essential to produce the good bond between them. And factors affecting the flow are melting range. Solders with a short melting range have a better flow, and oxides, if present, they prevent the flowability or wettability of the dental solders. Next is the heat source, which is the most important part of the soldering procedure, and commonly used instruments are gas air or gas oxygen torch. The flame must be good enough to provide enough heat for soldering. Thus, the flame should not only have a high temperature but also a high heat content, as if the lower heat content will increase the soldering time, and it increases the risk of oxidation, and which reduces the strength of the solder joint. Here you can see a soldering torch, which is handheld soldering torch. It is most commonly used in the clinics. An orthodontic torch which adjustable flame is used in soldering. The flame of the torch should be adjusted to 3/4 of an inch in height. The air is adjusted so that the slight hiss can be heard during the soldering. Now we should know the zone of the flame which is to be used for soldering. As you can see, the flame of the soldering torch is divided into 4 zones from inside out. In the diagram you can see cold mixing zone, which is unburned gas, which is a non-combustible zone. Next comes the partial combustion zone, which is also oxidizing area, so it should be avoided. Third is the reducing zone. So this is the best zone to apply heat, as it is it prevents oxidation of the joint, and this thus increases the joint strength. And last, the fourth zone, the outermost zone, is the oxidizing zone. We should avoid always heating the solder and the metal to be joined, and should avoid heating this using this zone for soldering, as it is the burned gas, and again it creates oxidation. The portion of the flame which is neutral or slightly reducing part is most efficient for the heating. An improperly adjusted torch or improperly positioned flame can lead to oxidation, as I said earlier. It is possible to introduce carbon into the substrate and filler metal by using unburned gas portion of the flame. So carbon can be introduced in the soldered joint, which again weakens the soldered joint. So fuel gas used can be hydrogen, natural gas, acetylene, and propane. Propane is the best choice because it has the highest heat content, which is 2385 BTU. It is a good flame temperature of 2850 degrees Celsius. It's relatively pure compound. It is uniform in quality and virtually water free, and it burn free also. Next, I will show you a hydro solder. It is the soldering machine found commonly used in the dental hospitals and colleges. The fuel used here is methanol. It is highly toxic, and flammable gas used as evaporating fluid in the soldering joints. So to summarize, orthodontic appliances are combination of various components which are also available in the market pre-welded, but the basic knowledge of procedure is important for modifications in the basic appliance, so that we can modify according to the need, according to the patient, according to the cost. Again, we can solder various components to increase the effectiveness of the appliance. Thank you so much.